There we go. Cool. Okay, now we're recording. Constantine, it's all you.
Yeah, hello everybody. Thanks for joining today. As was common with Colonel like Folk, I just completed my slides literally 5 minutes ago. So if there are any typos in them, I hope you will forgive me. And I literally completed the library that I was going to present 2 days ago. So everything is very new, and there will be a demo, and it'll probably explode. Just gonna warn you ahead of time. That just goes with the territory. The
Perfect.
slides are right here. Yeah, you can follow them there. I'm going to share that tab now. Present now, a tab. There we go. All right, I'm going to make it full screen. All right, the title is called Patch Attestation with Patat. Stands for Patch Attestation, Patat. I'm from Montreal. I thought it was a very funny name because it's very French. So let's dive right in. So patches sent via email. Why, right? Is it still 1993? Why are we still doing this? Well, the main reason why we're still doing it is it's the only widely supported mechanism for fully decentralized development. There is no other mechanism that does not rely on any single entity. GitHub requires being able to connect to GitHub. GitLab requires being able to connect to either the central mothership of GitLab or your own installation of GitLab. If you are, for some reason, not able to reach out to it, if it's denial of service, if it's anything like that, then your development fully and completely stops. Patches sent via email is fully supported by Git. In fact, Git itself as a project is developed by patches sent via email, specifically for the reasons described above. Every now and again, people say, why not move it to GitHub? And the usual answer is, one, we don't want to depend on a single one commercial entity to remain active. We don't want to have a central infrastructure that everybody depends on for the functionality of the project. It doesn't mean it does not use GitHub. There's a way, for example, to send patches via a GitHub project. It's called Git Gadget. But in the end, everything is finally and ultimately happens on the mailing list where people receive mail, they review patches, they send their announcements, everything goes via email. It also allows for plurality of tooling. There's no one single tool that can be used for Git, for patches sent via email. For example, some people still don't use Git. They think it's still too new, even though it's over 15 years old by now, I think. People still use Quilt because it's just simple for them to use it via a whole bunch of patches in the directory that can review, that can modify the patches directly. Some people use STGit, which is another sub-project that interacts with Git. There are people who use Patchwork, which is fairly popular with people who are dealing with mailing lists and patches sent there, because it allows you to track which patches have been applied, which patches are still outstanding. But this is just a side tool that you can use to interact with patches and track them, but it does not require to exist. If Patchwork is down, you can still work with patches in your inbox. And SMTP is a robust platform. I mean, it's much maligned, but the main problems with it is not really a fault of SMTP itself. SMTP is multi-vendor. It has address portability, so you have your own domain. You don't like one SMTP vendor, you move to another SMTP vendor, or you set up your own. It's really entirely up to you. You're not locked in forever with your email address to any single entity, unless, of course, your email is at gmail.com, which is you're forever tied with gmail.com. SMTP can deal with censorship and abuse. It's got a 30-year popular history, much more than that, obviously, but 30 years ago, not everybody had an email. Now everybody has an email, and email gateways deal with spam. They deal with being blocked. They deal with being directly abused for sending other stuff. There is a whole framework that arose around this for dealing with it. Unfortunately, many proposed solutions to replace SMTP, they kind of hope that abuse never actually comes. But we've seen time and again that any framework that is popular enough to have enough eyes, people watching them, will eventually get abused in the same exact fashion as SMTP was. And SMTP is really also allows for, actually, it's RFC 2822 allows for mixed messages, not in terms of just harassment, but in terms that there is a part that is readable by humans, that can be part readable by robots, and it can all be part of a MIME structure that can be multi-part. And of course, RFC at 2822 is not just email. It can also be used on Usenet, which is pretty much dead. And actually, there's Eternal September that never ended, if you are old enough to remember it. I'm not, I just know about it. It's when the hordes finally infested Usenet, and it stopped being useful for everybody, specifically because there was just too much junk. And Eternal September is a problem that keeps happening with every messaging platform that comes to replace it, unfortunately, because, like I said, if there's enough eyes watching your favorite platform, there will be abuse coming, and there will be hordes investing it. RFC 2822 messages can also be distributed via aggregated archives, public inbox specifically. It will be a service like lore.kernel.org, which is an archival mechanism for mailing lists. Any questions so far? All right. So RFC 2822 attestation, specifically signed, cryptographically signed email messages. So end-to-end, there's two standards, really. One is OpenPGP, which is very old. It came out in the early 90s. Key distribution is a problem. It does not scale well. Key distribution is always going to be a problem. There's no simple solutions there. Mail client support for OpenPGP continues to be subpar. Some tools deal better with it. Some tools deal worse with it. Some tools deal not at all with it. Almost no good Android clients, for example, exist for OpenPGP signed messages. There's a K9 Mail, but whether you consider that a good enough mail client for Android, it's entirely up to you. Probably try to use it. There's SMIME, which is pretty much reduced to corporate environments these days, even though it had fairly good start-off point back in the early 2000s, probably. But at this point, only corporate environments, when they set up their Exchange servers or they talk between companies or in a specific industry environment, like that requires attestation for all messages. For example, in automotive or aerospace, it also requires that all communication is signed and attestable, and that an SMIME is quite widely used there. But outside of the corporate environment, almost nobody uses SMIME, specifically because there are almost no remaining public certification authority issuers. And they would go back to the problem of key distribution that doesn't just not scale well, it's just basically non-existent. There's one remaining CA issuer that will issue an SMIME certificate, to my knowledge. And that one does a very weird thing where it actually sends you the private key that you should be using, which is totally not how CA is supposed to work. Of course, there's also end-to-end specific, vendor-specific implementations, Proton Mail, how do you say that? Tutanota, etc. But all the communication is restricted to within that infrastructure. So you can send an encrypted message or a tested message from one Proton Mail user to another Proton Mail user. You can't take this easily outside and make this cross-vendor. And of course, there's a domain-level attestation, which is DKIM, which is domain keys identified mail. And let's look at that in a bit more detail slightly further. There are specific problems with patches and OpenPGP, and the same problem with patches and SMIME, and why it really is not used. If you look at, for example, Linux kernel documentation, it specifically tells you never ever to sign your patches with PGP when you're submitting them. And there's two specific reasons for it. If it's inline attested, which usually has like -- begin PGP sign message, and there's a message below, then there's a footer with actual signature to the message. If you've ever seen that, you'll probably notice that any lines that start with a dash are required to be escaped, so it mangles patches. If there's anything that you can't just delete the header and the footer, you actually have to unescape all those dashes, and that just becomes a problem. And developers hate it because it just requires them to keep an eye out for this one thing. The tooling may not deal well with it, specifically if you have Quilt or if you have any other tools that do not expect to have PGP signed patches, that will not deal with it at all. It will not deal well. MIME-based attestation is commonly used instead, so it doesn't actually try to modify the body. It creates just a separate MIME attachment with the signature. There are problems with that. It does not cover metadata of the message. This actually applies to the inline. You could, with Git, include the subject and the from that should be used by Git into the body of the message, but almost nobody does this unless the from is different from the header from. We'll talk about that a bit later. Mail use agents or archival services may strip the attachment. For example, if it's in a corporate environment and it comes in with an attachment with a MIME signature for OpenPGP, a lot of the corporate environments don't recognize this as something useful. And just in case, they just quarantine it or strip it so it just gets lost. And OpenPGP does not, this does not attempt to solve the key distribution. There is, it just kind of defers to whatever preferred mechanism for distributing keys with PGP is. Key servers or WKD, which is web key directory. Some mail user agents will actually now try to look up keys via WKD, but very few domains are supporting that. So, for example, if you have a Gmail address, there's no way to publish your public key for Gmail because it just does not support it. The same goes for many other very commonly used mail providers. Any objections to this? Everybody still here? Okay, good. That's it.
I object to the breaking code review, but that's not your fault.
It does break code review. I mean,
Right.
if you read Linux, the documentation specifically says not to do it for this reason, because it will break the patches. But all right, let's not to concentrate on that too hard. Let's move on to DKIM attestation. So DKIM, for those of you who don't know, is a mechanism that was created to combat spammers, specifically for impersonation of spammers of the main mail providers. Right? If you're a Gmail and somebody sends, "Oh yeah, hi, my from is Gmail," you want to make sure that when somebody receives that email, they know for exactly right away that it was not actually sent from Gmail, that it's spoofed. And for this reason, the DKIM attestation standard was created. And it's actually pretty good if you look at it. It covers header metadata. There's a header that I include here. This is what the standard DKIM signature is as generated by Gmail, sent by linksfoundation.org, which uses Gmail for this. You will see that it has covers header metadata. It says the H line says the following headers and their contents have been included in the final hash. And when we validate it, we look at the same headers. We add them to the signature, to the hash when we generate it. And if they're all the same as when the signature was generated, then we know that none of the headers have been modified en route. It includes the body hash, which is actually not a lot of people know that this line here is the SHA-256 of the entire body of the message. It's canonicalized using the relaxed standard in this particular case. So this is slightly confusing. Relaxed/relaxed. It just means what the canonicalization is used for headers, which canonicalization is used for body. And we'll talk about this in just a moment. It is easy to implement. It's actually just maybe like 100, 200 lines of code to completely re-implement the DKIM standard, because it's very simple outside of the actual crypto. The actual crypto that handles the signature is obviously outsourced. You don't want to implement it on your own, but the actual standard is very easy to implement. I've done it multiple times. It is an open standard, and it is very widely used. Almost every major email provider will DKIM sign their messages. So is DKIM good enough to attest patches? Well, it is, but with a few caveats. First of all, you know nothing about this infrastructure that actually is doing the signing. I mean, if you send email via kernel.org, you kind of trust me that I'm doing the right thing with the private key that is used to sign the headers, but there's no such, there's no auditing standards. There are no requirements, like with the CA infrastructure, for example. If you're setting up your own CA, there's a whole bunch of things you have to jump through, hoops you have to jump through to prove to everybody that you are worthy of being considered a CA. There's nothing like this for DKIM attestation. It's basically kind of you're trusting that the domain is doing the signing, has done the right thing with the keys, and they're not just lying around in the main web directory. It obviously depends on DNS, because when we look up this, right, if we look at d equals linuxfoundation.org, it says domain that signed this, linuxfoundation.org and select there's Google. Google, when we look it up, we are looking up for a domain record called google._domainkeys.linuxfoundation.org. And that's how I obtain the public key used to verify this signature right here. Obviously, DNS can be spoofed. It could be any number of other ways. It could be invalidated and substituted for the wrong public key. DNS zones can be signed using DNSSEC, but few are, and repeated attempts to make the end clients validate DNS signatures are kind of non-existent still, or not successful. We talked about the relaxed body canonicalization. It's not great for patches, specifically because the standard says when you find continuous white space, you replace all of it with a single space, which is, if you're sending patches for environments like Python or Makefiles or some number of other projects or programming languages, then obviously with a return that is outdented a couple of times could be a security vulnerability. And if somebody is wanting to mess with you, they can replace a patch with something that actually says something else.
Constantine?
Yeah.
David Wheeler. I hadn't thought through the implications of that. Has anybody thought about maybe proposing a DKIM tweak or something like that, DKIM tweak, so that it would skip, hey, include this header, and then we'll skip the body canonicalization, or provide here's the extra information for the one that wasn't canonicalized this way. Something to overcome this.
There is no way to overcome this because this is a part of the standard. But if you are using the simple canonicalization, then this is not a problem, because simple canonicalization just means replace all of the line endings with CRLF instead of just LF, and remove any trailing white space, so at the end of the message, which is okay. It's not a problem.
Yeah, but that's almost never a problem. Yeah.
Yeah. So if it's if you look at here and if C says relax/simple, then it is okay. For example, kernel.org, when we sign, we always use relax/simple, but obviously a Gmail or many other email environments, if they use a relax/relaxed, then this is going to be a problem. This is not good enough for patches that have syntactic white space. And if this was for just for Makefiles, then obviously this is okay. But Python is one of the most popular projects worldwide, right? So we cannot rely on this to do the right thing for DKIM signatures. So the tooling could mark, for example, when we're checking DKIM signatures, we can say, this is signed with relax. We could give it like a lower score or something like that, but then it just kind of details that are going to be obscure to developers, because very few people understand what this is actually implying. But it's better than nothing, right? So this is DKIM signatures are great for the absence of everything else, right? Because it says that when this message was leaving the domain of the originator, the signature was created, the body hash was signed, the message headers were signed. We can validate that none of them have been modified in root. As a dishonorable mention, mailing with software that mangles existing headers or bodies. This is still a widespread problem. Please, if you have an infrastructure that manages mailing lists, please stop doing that. Just insert extra XList headers, whatever it is that's necessary. Rewrite the envelope but don't touch the headers that are otherwise in the message. Like Mailman2 is dishonorable mention. Groups.io, dishonorable mention. Google Groups, dishonorable mention, because they all do that.
Are there a set of tools that we could push patches to fix these things that are popular, or is this
Well, Mailman2 is dead. Unfortunately, Mailman3 is a beast. So a lot of people who kind of looked at Mailman3, especially if they've done it some years ago when it was in a fairly messed up state, they kind of said, no, I'm just going to stick with Mailman2. And you can configure Mailman2 to not do this, but by default, Mailman2 will add the little footer at the body of the message. It will add the little prefix to the subject to identify the list, which was sort of a nice thing to do back before DKIM was a standard. But unfortunately, doing this now will certainly invalidate DKIM signatures. So if you are running mailing software, please stop doing that. All right. So what I suggest is that we adopt DKIM for our purposes. We basically create another header that's very similar to DKIM, but we do some funky things with it. Specifically, we add some minor twists. We only sign the from and the subject, and we create the body canonicalize it, but we canonicalize it using get mail info, which one of the problems that I ran across when working on this is iteration 3 of my proposal, is that if we sign messages before they leave a developer's workstation, there is a good chance that the message body is going to be recoded, for example, using coded printable or using base 64. And then when DKIM signs it, it's not a problem for them because they're not going to do any of the recoding, but the mail client software is likely to do something like this. So if we pass it through get mail info will actually unencode all of those things, put it back in 8-bit, and take care of doing the right thing. We obviously are not using DNS for key distribution because we're not domain level signing, but we'll talk about that later. And we're going to add the OpenPGP into the fray. If you look back at here, the DKIM signature, the A line says what is used for signing and what is used for hashing, right? So when we generate hashes, we generate them using SHA-256. When we create the signature, we use RSA keys. I say that we are going to also add OpenPGP into this because OpenPGP is a widely used standard with developers already. Here's an example with OpenPGP SHA-256. You will notice how very similar this header is to a DKIM signature. We have same v equals 1, which means a totally different thing here because it's a different standard. We have the A, which is also says how it's been signed, how it was hashed. We have an L line, which I will explain in a moment. We say which headers we've signed. For Git purposes, we only really care about the from and the subject. And then we'll leave date out because Git send email will actually change the date before it sends it out, which kind of really, really annoys me. But then when I asked this on the Git list, I said this is as intended because reasons. We include the body hash. We include the actual signature, which is the PGP signature that's base 64 encoded. The L is kind of important here for our purposes because after we get mail info, canonicalize it, we say when we did this, the length was this long. And if a mailman list adds that junky footer at the end, we can then revalidate this saying, well, if we try to actually look at the length that the original sender said it should be, this actually passes. This must be treated with caution because if the actual end client tooling is not expecting this, this could insert things into the patches that we've did not validate. Kind of the same problem with inline PGP signatures that could just include the chunk of the body, and then it could be unsigned stuff at the bottom. And when the end user agents render it in the main view, it may not indicate where the actual signature ends and where unsigned content starts. Same problem here. All right, and there's in addition to OpenPGP, we also do ED25519 signatures, which is a standard. It's actually used with DKIM. You can sign DKIM with ED2559 keys, not just RSA. Very similar here with a few more things. When OpenPGP signs something, it includes the timestamp of signature of signing into this whole junk right here. So we don't need to actually specify what time it was signed at. Since we don't include the date header, we want to make sure that nobody tries to replay some old signatures from a long time ago. So about ED259 or 99 EDSA does not include the time of signing into the signature itself, which is why it's so much shorter. But we include it into the header when we use the standard. We also still include the length, and we include the identity of the person who signed this. And the identity is also only included when the from, as Git sees it, is different from the person who is actually attesting the message. For example, if I'm a sub-maintainer on a project, I could be receiving patches from many, many different people, but I want to make sure that when somebody tries to validate the attestation, they see that it's been attested by me, not by the original author. So we include the I of the identity of the person who's doing the attestation. We'll also include the selector here, which is very similar to DKIM, and it's kind of a hint to the validator saying where they should be looking for the key. All right. Any immediate comments?
Yeah. You probably already said this, and I might have just missed it. The B here is the signature. Is that a signature just over body hash, or is it a signature over body hash and the other parameters like the time?
Yeah. So if you look at the DKIM standard, the way this hash is calculated, it takes every header that is listed here. So we take the first of all, we add the body hash, this, into the signature, into the signed content. Then we add every header, and then we add this whole thing right here up to and including B equals. Right. So this part includes all of the headers, and this includes this header itself, right, with the BH in here. Does that make sense?
Yep, that makes sense.
Cool. DKIM is clever. I kind of enjoyed it working with it. All right, so let's look at the tooling that I proposed, the patat, the funny name, silly name, serious business. There's it actually means something in Norwegian. It's false. That's actually what it means. It's false. It's a dead joke. You know the false meaning? Haha, very funny. All right, you can find the project right here on gitkernel.org. You can also find it on GitHub if that's your thing. It can be installed with pip install patat. It's a Python program. You can install from PyPI. It's really only a few hundred lines of code. Actual crypto, of course, is done with Lipsodium with Pineapple, and GNU-PG if we're using OpenPGP. It runs with anything Python 3.6 and plus, which is the oldest supported version of Python. The intention is to use it with send email validate hook, and I will show during the demo in a moment. So who should be signing patches? All should be signing patches. I think everybody should start using this. Obviously, otherwise I wouldn't have written this tool. Let me do a quick demo session right here. Let me stop presenting this tab and start presenting a different window, and I hope that's still around. Very good. All right. You can see me typing this. Right? Good. Excellent.
Yep.
All right. So this is just an Ubuntu 20 something. Ubuntu something like that. I don't even know how to check that. I just wanted something I don't usually use to make sure that it works. I usually a Fedora person, but I specifically a Ubuntu system saying that this is a cross distributions. So let's install patat. First of all, I'm going to create a new virtual environment just to make sure. What was it doing here? There we go. Demo. Patat. All right, there we go. Patat. There we go. It's installed. It's working. We can. I've pre-cloned it right here. We can immediately validate something. Samples. Great. There we go. Crash. Yeah, it's validate samples. There we go. So where did it get the keys? I didn't preload the keys there. We'll talk about it in a moment, but it actually is included in the repository itself. If you go to keys, there's 2 directories there. You can find that the keys actually included with this. And if we look at the samples, that's where I took the example lines from. You can see that it includes the X-developer signature right there. That includes the X-developer key, which is literally just the key information. And it's not used for validation. It's literally just for when the message is put into the archive, we can go back and see what the person's key was at the time when they were sending the following patches, assuming you trust the archives, of course. In the case of this ED259 keys, it includes the actual public key since it's so short. In the case of OpenPGP signed, It just includes the fingerprint of the key because they're too long. It doesn't make sense to include the actual OpenPGP key with the headers. They will just be humongous. All right, so let's generate the key. Let me just make sure I removed all the old ones. I was testing this. Move all of them. Of course, I'm fat fingering everything. There you go. Ta-da! There, I just generated a key. It said that it wrote out private key in the private directory, public key in the public, and also put it into my own local keyring right there. And what am I supposed to do now is just to include this part into the git config. So I remove the old junk there. Yeah. So now if I do git format patch one stout, I can do that sign. Boom, it's signed. It's right there. I have the ex-developer signature. It says when it was signed. It's got the length of the entire thing. It includes my new key that I just generated into here. So when I send it out, it will be added to the public inbox archive on lowerkernel.org, for example.
Yeah, can you push up arrow 1 to see the command you used to do that?
Yeah, there.
Okay.
Now,
okay, so you're generating a normal one, and then you modify it to add the signing.
Yeah, but the idea is that you're not going to be using it this way. What you are supposed to be doing is to add a git email validate hook. So if we go, I think I already did it before. Go to the hooks directory. There we go. So the send email validate hook will run every time git send email is executed. And this what we'll do is we'll add the signature to every patch that git send email will be sending out. And let's do this right away, actually. Let me remove the old outgoing. Let's say git format patch. Let's say 3 of them. And outgoing. Right. So this is the last 3 commits for this repository. One, you can see that it does not have any signatures there yet, but it includes everything stuff that I actually worked on. So since git commit hook is already there, not commit, the send email validate hook is already there. What I'm supposed to be able to do now is say git send email. I'm going to suppress CC auto just for the. I'm going to send it to a special list I've been using for this. Yeah, outgoing. I think that's all of it. Sorry. All right, you see that it's signed them. Signatures, great. I am fat fingering everything today. There we go. So if you go to lore.kernel.org, I'm not going to share that here, right here, lore.kernel.org/signatures. It should be at the very top there. Not yet. Come on, hurry up. That page is cached, unfortunately. But what I can do is the stuff that I did previously. Just copy the very first top right there. Except it's not going to validate because I deleted that key.
Yeah, and we actually can see the ex-developer signature right here.
Yeah, you can look at the raw. You can sit there, but it's already there. If you refresh that page, the localkernel.org/signatures, you'll see that run better result with just pass fail was sent just right now. There's 3 messages there. And all we need from there is that's message ID of the stuff that I just sent. Let me share this with the chat. That's the link. If you haven't found it yet. So what I'm going to do now is going to demonstrate with B4, which is a client-side tooling that many kernel developers use to interact with patches sent to mailing lists. What I'm going to do, I'm going to go to B4, pip install requirements. So we need a few more things on a brand new environment. There we go. It worked before. I'll try it again. That says it works. So let's hope it worked. So I just, since it's a development version of before, I can't let people install it. So I'm just running it directly from a Git checkout. And so it works. I'm going to paste that URL. There we go. You can see that it retrieved it from lore signatures. It already did it. It went ahead and validated the DKIM signature on it because it does it by default. It says that the was signed by linuxfoundation.org. That signature passes. But it says that when it found the key that was used for patat signing, but there is no such key. We don't know this key. So it does not automatically import the key because obviously that would be a terrible idea. But what it allows, what we can do with before, can just show keys. I can say, grab the thread, found all the keys that are used in it, said, I found the following key type. This is the public key for it. This is the path that we should be using when we import it. And the full path, if you wanted to import it into your local keyring, is the following. So we're going to do exactly that. So we're going to echo that into that. Right? So when we run the before I am, oh, there he says, it's been signed, it's been validated. And now every time I receive the patches from this person whose key I already have in the keyring, it's going to show me it's been signed by this. If we try to change any aspect of the, for example, right here, samples, let's do, we're going to change this for the exclamation point. Obviously, the hash is going to be different. There we go, crash, boom. That's right here. There you go, it says a bad sig, it failed to validate using the key that's bundled with our Git repository. All right, that's the end of the demo. Any questions?
Yeah, obviously you showed how to yank those keys, the public keys in. For some small projects where there's only a couple of users, I can see that being not a big deal, but Linux kernel is not a small project. Any ideas on how to make that handling of the public keys better?
Yeah, you're jumping ahead a couple of slides. One moment.
Okay.
All right, let me reshare the presentation. And of course, you can run those tests all by yourself. The patat is perfectly installable right now. Before development version, if you wanted to look into it, you can perfectly do that too. Slightly more work. All right, present a tab.
Constantine, small bit of probably like just dumb feedback. You may consider fingerprinting the ED25519 public key too, unless you have a use case where you would want somebody to use it from there, just for misuse prevention. Because if that public key is in that header, someone may be tempted to use it to try to validate the signature, which obviously wouldn't be a secure workflow.
Yeah, well, I mean, we can't, right? I thought about this, but I thought just it would be easier to go back to archives and to see that key directly there. In the documentation for patat, it says that you should never use this specifically for validating the signature that is in the same message, because that would be obviously dumb. But I mean, if somebody wants to do something obviously done, there's only so much I can do to prevent them from doing this.
Yeah.
If you wanted to repeat the instruction here. So OpenPGP versus ED25519 keys, which one should you use? I say NuPG, OpenPGP is preferable, simply because it can be used to sign patches and Git commits the same. For example, PGP is used for Git tag signing, Git commit signing. So if you are a developer who already works with Git a lot, you probably already have a PGP key, which is the main reason why I included the option to do it. It can be imported to GitHub and shared that way. For example, if you are just participating in a project and you have a GitHub account that could be sort of used as a trusted introducer, a CA of sorts, saying, if there's a two-factor authentication on your account, you could probably get your public key from your GitHub page, maybe. Main reason why I want to use this is the keys can be uploaded to hardware smart cards, which you cannot do with ED259 keys very easily. You can get a YubiKey, a Nitro key. You can put the signing key onto the hardware device, and the key that's using for signing patches and your Git commits is not on your main system. And you can pick it, you can take it with you. You can travel between workstations, laptops, and don't have to worry about the key being somewhere on the disk. With the new version of GNU-PG, you can actually seal the key with a TPM, which is kind of neat, cool feature. And of course, the GNU-PG standard can use ED259 keys as well. So when we say OpenPGP SHA-256, this is actually a bit of a misnomer because you can use ED259 keys via PGP itself. But ED259 keys may be preferable because it's the lowest cost of entry. Like you literally run one command and the keys are generated. There's smallest signatures that are created. And of course, GNU-PG is dramatically larger compared to libsodium. Libsodium is a fairly small code base. So if you wanted to do the least amount of legacy on smallest keys, lowest cost of entry, you would go with ED259 keys. Okay, so managing the keyrings, the question that David, you asked a little earlier. So the idea is that we'll stick the keys into the Git repositories themselves. It's not as crazy as it sounds because it's not really any less safe or less secure than using something like key servers. If you just because you retrieved a key from a key server does not mean that's the valid key. You're supposed to be using cross-signature validation, but let's just not even go there because so very few people understand how exactly it works. And even those people who do surprise me periodically, right? So if we put it in a Git repository, the Git commits that modify the keyring can be themselves signed using a trusted set of PGP keys. So for example, if you are using one of my projects, all of my commits are signed by my key. So you only have to validate one key and verify that my key is valid. You can do it face-to-face. You can check the signatures on my public key. You can just download it from my website or something, one or the other, just one key. And after that, all of the keys that I'm of the committers to my projects would be in the Git repository signed by my key. Similar idea, like we do cross key certification, except now it's just in one Git repository. And so I'm acting like a certification authority or a trusted introducer to all of the other keys in my keyring that I distribute via my Git repository. Now, for small projects, it can be kept in the main development branch under the .keys or .keyring, like I did with patat. There's two keys there for samples. When we just install it and run patat validate, it takes those keys directly from the Git repository itself. For large projects, obviously, is a problem because that's just too many people, right? Linux kernel, you can't possibly have just one keyring for everybody. So the idea is that sub-maintainers will keep their own keyrings just for people with whom you work directly on a day-to-day basis. It can be in its own ref. For example, it could be refs meta keyring. It could be refs had some common branch name. It can be an external repository, which I'll go into in a moment. It could be a fall-through combination of all of the above. It can say check the main project keyring, check my ref in my particular repository keyring, check my local keyring, find a key in any of those. Whichever one comes first wins.
Why do you say it's impractical for it's too many people? This is all machine read, right? There aren't people that have to go deal with this.
Well, somebody has to review it and commit it, right? So for example, I think it's just going to be too much work for somebody like Linus, for example. If you wanted to maintain the keyring, maintaining it in the main development branch under refs heads master would just be too much work for him. He's not going to do it because it's just he doesn't scale. I'd say this will not scale to Linus. That's
the bottleneck isn't in the tooling; it's the
correct
the committing.
Yes. Right.
Okay. But I have to admit, I'm not sure I see that. I mean, he immediately delegates as he should.
Mm-hmm.
For a large project, what I would expect would be that Linus wouldn't just accept a random addition for a keyring from random anyone. He would expect, hey, I'm the maintainer of this subsystem, and I have added this and signed it because this other person is indeed, I've checked this person out.
Right.
So I hope eventually it will go there. If we start right off with, hey, Linus, maintain this keyring, it's just not going to work.
Sure.
Oh,
So the idea is that we'll start off with not touching Linus, not sort of going there yet, but with sub-maintainers maintaining their own keyrings. And then if it is working well for everybody, then we can come at the kernel summit, for example, I can say, this is a system that's been working well. It's prevented the following, hopefully prevented following things. It seems to be simple enough, and developers are not finding it cumbersome to use. Let's have a central keyring. And I also slowly sort of go into this in the next slide, I believe. Okay, the keyring structure, 10 minutes left. I'll try to run through it. It's only a couple of slides left. So when we look at the signature, there's a couple of things that we use here. First of all, it's the identity, of course. Second of all, is the selector that we have here. What we do with this is there's a key type, which is the algorithm, ED25919. I never say the numbers in the right order. Then we have the identity domain, so we have kernel.org. Then we have identity local, Mr. Icon. And then we have the selector, which is this. And this is how we say this is where the key is supposed to be. In any of the keyrings that you've specified, we will look for this key type, identity domain, identity local selector. So for my local B4 keyring, I would say this would be in the following location. ED259, kernel.org, there and there and there. They're all in separate files specifically because I do envision that at some point they will be sent as part of a regular pull request. So I wanted to not have anybody deal with merge problems because, well, multiple people are changing the keyring structure by itself. So I wanted all the keys being in their own separate files. This is the fewest problem for Git maintainers. If there's no clashes between if there's a clash, you know exactly the problem is somewhere, that somebody's submitting different keys for you. So the ref-based lookups, the following structure. We can, for example, say keyrings SRC in B4 in the current development version. You can say, look in this ref. There's 3 parts to it. You can look in the current repository that I'm using. Look in the following ref's meta keyring. And then at the top level, it will be ED259/domain/local/selector. You can look in all parts missing, just whatever branch is checked out, look for the .keys directory in there. You can also look in my top level, just regular directory. Just look without the ref. Just look for keyring/ED259 domain local selector. So the ref's meta versus ref's heads is arbitrary. Ref's meta will hide it from most of the UIs on the web, for example. If you didn't want to just literate your view, you can just put it into a separate branch. It's perfectly fine. If you look at the patat documentation, it says how to create the ref meta keyring, how to maintain it. I did mention my own keyring. If you go to this URL, I do maintain about 300 keys for kernel developers, and that repository is ready to work with B4 and patat. And it's supposed to work with the fall through in the order that is listed. All right, last slide before I'm done. So whose keys should be added to the project keyring? It does not make sense, obviously, for one-off contributors. You're not benefiting from it in any sort of way. Somebody just sent one-off patch and they signed it, whatever. If you add it or don't add it, it's not going to make any difference. You should assume that their code is untrusted, malicious, and reviewed with extra zeal. But the problem is that maintainers don't scale very well. So if you have an ongoing long-term relationship with somebody who sends you code all the time, then it makes sense for you to implement this system and add their key to your local keyring, to the in-repository keyring, because this will help you scale. This will help you catch obvious tampering or obvious corruption of the patch for some reason, not malicious, just dumb. And of course, you also have to keep in mind that it can still be malicious because the keys can be stolen, even with perfect crypto signatures. So this is kind of prevents an aspect of badness. It does not completely negate badness. You should always use vigilance, reviewing other people's code, whether it's signed or not signed. Okay, that's the end. Whew. If you have any questions or comments, feel free to voice them now. We have 5 minutes left. You can send an email to tools@linuxkernel.org, where I will be announcing patat later today. I was kind of rushing it to make it ready for this presentation. If you
Are
would
any
like.
of the kernel.org lists set up to do this already, or do you have ones in mind?
No. I will reach out to a couple of them. Yeah, but this is literally so new that nobody's using it yet.
Okay. So obviously we send a lot of kernel patches, so we'd be open probably to doing a pilot. I can run it through our kernel team.
That would be awesome. Hopefully it's straightforward enough. And like I said, the library itself is so small, you can review it to make sure it's not doing anything terrible or weird.
Yeah,
Most of
I'll
the
make them
code
aware of
there
it.
is, most of the code is there just scaffolding saying, the following command line switches, and the actual crypto is like within 200 lines of code.
Okay, cool. Yeah, reach out to me when you're ready to start doing it, and I'll at least make sure people are aware of it. We can probably figure something out.
Any other comments?
Thanks, Constantine. My question was more, is this applicable to anything other than sort of the Linux kernel development flow with like the mailing list and everything?
Well, I mean,
is it
so it's called a developer signature, but it does not have to be just for patches. Just the way we canonicalize the contents is specifically for patch workflow. But if somebody wanted to take this idea and extend it to just let's re-implement PGP signing, but directly with headers, we could theoretically do this entirely, which is to canonicalize using the regular, DKIM standards, whatever it is.
And it's tied to PGP, though, is that?
No, not tied to PGP. You can use ED259, and you can use any algorithm there. I didn't implement RSA because I kind of hate RSA, and that would require pulling in so many more Python libraries that I just didn't want to go there. But you could have RSA 256 to be exactly like DKIM. Any post-quantum algorithms that come out in the future, we could just plug them in directly via that, or we can just use OpenPGP to wrap sort of around it. OpenPGP is literally just a scheme. It's not really an algorithm, which is kind of why I kind of hate and like the name. It just tells you what you should be using, but it doesn't tell you how actually the signature has been generated.
Gotcha. David, did you want to?
Yeah, so we're almost at time, but just want to give people a quick heads up. Another effort in parallel is Dave Hoosby is working on extending Git to enable it to support many different signing systems, basically able to call out to scripts, and instead of having just the fixed system it currently has. So I posted in the chat a URL where you can go see his stuff in draft. It's not done, but it's here. It's a first cut of the patch with some patch reviews, with some review from the Git maintainers. And I'll just quickly summarize the bottom line. That was basically overall generally positive. The approach needs some refinements, which Dave Hoosby knew anyway, but I think it's certainly looking promising on that aspect as well. So I realize we're almost out of time.
Sweet. Yeah, I'm going to share the recording once I upload it to a few folks around Google and see if I can get some feedback on it too.
Yeah, I would love feedback. This is try number 3 for me. The previous 2 tries were not going anywhere. And the one that I had before this was with 3 different hashes, what I broke down, but it required parsing the patch contents, and I hated that whole idea. So we just say, let's do it the dumbest possible way, which is also the simplest. And I think this is more likely to actually take off.
It's really cool, Constantine. I like it.
Thank you.
Cool. Well, thank you, everyone. We will follow up on some of the rest of the agenda items next time. So have a good rest of your week, and good seeing you all.
All right. Bye, everybody. Thank you.
Bye, everyone. Thanks.
Thanks.
Thank you.